Hi, I'm Matt, and in this video we're going to go over entropy. Be careful not to confuse this with enthalpy, as that is heat energy and is a different thing than entropy. So firstly, what is entropy? Entropy is a measure of randomness or disorder of particles in a system, and we use the letter S to represent it. And in nature, systems move towards an increase in entropy, or they move towards a positive delta S value. In this video, we're not going to get into calculations involving delta S. We're just going to go relativistically, such as what has more entropy than something else. Now, we're going to go through the states of matter and discuss their relative entropies. So first, we're going to start with solids. In a solid, the particles are very close together, and they maintain a definite shape and a definite volume. The particles can't move very much and really just vibrate in that same shape. Because the particles are confined to that shape, we say there's very little disorder or a very low value of entropy because the particles are fixed. The next state of matter we are going to discuss are liquids. Within a liquid, the particles are close together, but they're farther apart than they would be if they were in a solid. Liquids have an indefinite shape, but have a definite volume. You could think of water, how it flows in and out of stuff, and it takes the shape of the container it's in. Because the particles are able to move over each other and are able to make the shape that of the container they're in, we say they have more entropy than a solid, because there's more disorder as they're able to move around more. The next thing we're going to discuss is the aqueous form. This is not a state of matter. This is when we have ions dissolved in a liquid, such as salt water, where we have Na plus and Cl minus ions in the water. And we say that this has more entropy than just a liquid, because now you don't just have the water molecules, you have the water molecules, your cations, and your anions, or your positive and negative ions, in the solution that will mix around. The last state of matter we're going to discuss are gases. The particles are far apart and bounce off the walls of the container. You could see this beaker, I drew a cover on top of it, because otherwise our gas particles wouldn't stay in the beaker. Because gases have an indefinite shape and an indefinite volume, so their volume becomes the container they are in. Since the gas particles are moving around in all directions and colliding, this has the most entropy out of any of the states of matter or the aqueous form. So in summary, gases have the most entropy, aqueous have the second most, then liquids, and then solids have the least entropy. A good way to think about this is imagine kids in an elementary school. So solids is like the kids sitting in their desk, they're moving around, but really they're in their seats. Liquids would be like the kids in the hallways, moving around, walking in somewhat of a straight line, but a little bit more movement than they were in their seats. Now let's say there's multiple classes in that hallway, maybe during a fire drill. So you have all these different classes getting mixed together, would be similar to the aqueous form. And then gases is recess. You have the kids running around all over the place. So that's what I would use to try to remember the order of these states of matter when it comes to entropy. So now that we know the relative entropies of different states of matter in the aqueous form, now we want to look at a reaction and be able to tell if entropy has increased or decreased. So how do we know when entropy has increased? Well, entropy increases whenever we move up on the chart from the previous slide, such as if we start with a liquid and it becomes a gas. We could also say we have more entropy when we get more moles of a certain gas, or more of an amount of certain gas, such as 2 moles of gas becoming 4 moles of gas. More gas particles, more entropy. It also doesn't specifically have to be a gas. If we have 2 moles of solid and it becomes 10 moles of solid, that would still be an increase in entropy because we have more particles. We also could have any combination of the above 2 bullet points, where we could create more moles and move up on the chart, such as 2 moles of liquid becoming 3 moles of gas. And of course, if we go backwards from any of these bullets, such as a gas becoming a liquid, entropy would decrease in that direction. Now let's try a practice question. So in the reaction 2 solid Na plus 1 gaseous chlorine creates 2 NaCl. So we have to look at what's on each side. On our reactant side, we have 2 moles of solid and 2 moles of gas, and on our right, we have 4 moles of solid. Now, we have to look here and say, okay, we had some gas on the left, but now we have all solid. Since we no longer have gas, the entropy has decreased in the reaction, since everything is now in the solid form. Now let's try another example. In the reaction solid CO2 becoming gaseous CO2, does entropy increase or decrease? So on the left we have 1 mole of solid, and on the right we have 1 mole of gas. This is that first bullet from the slide, where we move up on the chart. So gases have more entropy than a solid, therefore the entropy would increase in this reaction. So the last question we're going to do is 3 moles of iron undergo condensation. Does entropy increase or decrease? So the first thing we have to do is figure out what condensation is. You may remember from when your teacher went over phase changes that condensation is when we go from a gas to a liquid phase. So here this could be written as 3 moles of iron in the gas phase go to 3 moles of iron in the liquid phase. So now, remembering our chart and the order of entropy, we would know that entropy decreases because rather than the particles flying and bouncing off places in the gas phase, they're now together in the liquid phase. So now that we've done some practice together, here are 6 practice questions that will help you review the concepts in this video. At this time, I encourage you to pause the video and try them on your own. The first 2 are more conceptual, while the third and fourth involves you analyzing a reaction and saying if it increases or decreases. And 5 and 6 go through phase changes and how that affects entropy. The answers to these questions will be provided for you on the next slide. So in order of increasing entropy, we should get that they go solid, liquid, aqueous, gas. And then in nature, reactions go towards a higher level of entropy. In the reaction in question 3, entropy increased. In the reaction in question 4, entropy decreased. And the processes described in 5 and 6 would both cause entropy to increase. Hopefully you got these. If not, feel free to leave any questions in the comments below and I will get back to you as quickly as possible. Thank you for watching and have a nice day.